Okay, so today's 5/27. This is video 105, and I'm doing yesterday's assignment number 39. And I noted here yesterday on the board here that these are problems from the Regents book. So I'm going to do these problems on the board, and then immediately I'm going to send you another assignment and let you work on it. So I'm going to give you a little time to do that. So today is sort of like, can we do these Regents problems? That would be the focus of what I'm doing right now. So I'm going to start with number 31. And like I said, I'm going to reassign the next numbers. These numbers are the numbers from the Regents book. Notice I only gave you one problem with two variables, so maybe we'll do a little bit more time on that. So I look at number 31, and I'm turning my attention over to the right-hand side of the board, and giving myself all this space I plan to use is on this side of the board here. And I take a look at this, and it's 12x minus 9, and it's an algebraic expression. It's linear. If you like, it has a slope of 12 and a y-intercept of -9. It's a linear binomial, and you're asked to completely factor it. Well, most people do these problems by inspection. The answer is that 12 and 9 share the 3. And so just working backwards, there's your factorization. Go check yourself. Okay, and you can clearly see that that's the correct answer. Another check would be, and a more important check I might say, are these two leftover terms coprime? And we talked about that. That's very important to make sure that you factored it correctly, or as they say, completely. Another way to do it, which seems to be too much work, is to completely factor these guys. I'm doing prime factorization, although you don't have to do that. And there's no x on this one. That's the whole point. And this is 3 times 3. And what matches? The 3 matches. There it is. So it's much preferable to do mental math here. But however, as I'm showing you over here, if you like, you could prime factor this or even use 4. But whatever happens, you'd have to match the 3's up. As I repeat one more time, it's much better to use mental math on these problems. So anyway, that's the answer for the first one. It's 3 times x minus 3. Okay, and I'll be doing the next one now. Let me just get a dry towel to make sure that we're not writing over wet surface here. Okay, and now I go immediately on to the next one. And it says 18x squared plus 54. So that's their problem number 32. Well, the best way to do this problem is to notice that 54 is a multiple of 18. If you don't know that, then you're going to have to factor. And it would be easy to do so if I put them like this. And there we go. But really, like I said, how can you compare the two methods? To see that 54 is a multiple of 18 is the best way to go. And half of 54 is 27. So you see, I'm just doing the math of 6th grade. In fact, when I do coverages, I teach them this stuff. And then I line them up. Okay, and there's a 2, and there are 3 3's, and as you can see, the numbers match up. 2 times 3 times 3 is 18. So what would you rather do? See that 54 is a multiple of 18, or go through all this 6th grade stuff? It's up to you. If you don't see them, then that's what you have to do. So I extract the 18. Okay, there's a little moisture here. So whoops. So I extract the 18, and what's left? Well, x squared, and how many times does 18 go into 3? There's the answer with the factorization, plus 3. Now, are these two numbers coprime? That's an important question to ask. Well, yes, they are. They cannot be put together. They cannot be factored by any number but 1. So that works. 18 times x squared is 18x squared. And 18 times 3, which you should know by the time you're in high school, is 54. So here's the correct answer. And you should be able to do that. It's a very reasonable Regents question that they asked you here. Okay, so we got that one down. And you can always pause these, to see exactly what I'm doing or communicate with me if it's too much, but it really shouldn't be. Okay, I go on to the next one. I might speed up a little here. I'm not on this one. On this one, it's not obvious what the GCF is here. So I'm going to quickly do the math. Kids who are good in math will see that it's going to be 12, but I can see, it goes fast, but I'd agree with kids who don't want to do this, okay? There is another way called the Euclidean algorithm, okay? So I put all those together, and that's good for bigger numbers, but here, we're just going across. You see what I'm doing? I'm working really quick, and 108, because that's all I care about. I know I'll factor out the b's. So 108 is 2, 2, 3, 3, 3, and there's 2 b's there, and 60 is 2, 3, 5, okay? And let's make sure we got that. We're missing a 2 over here, so there's a 30. So it's 2, 2, and we double check that. 4 times 15 is, and then of course we get our GCF, which is 12. So very irritating to do it this way. They're not really intending that. So you might even be better like with a guess or check thing. You know that 2 works, different ways to do it, but this is the easiest way I can think of when the numbers are small, okay? So anyway, be that as it may, the GCF of 60 and 108 is 12, and you'd be responsible for finding that, okay? And so let's see, so we got that, and we extract out the B, and what are the remains? Well, let's see, 12 times 9 gets the job done here. Better add the B, because that's what we were matching up before. And 12 goes into 65 times. We check 9 and 5 are coprime, or better said, the 2 terms, 9b and 5 are coprime. I double check, I go backwards, both work, and there's your correct answer, okay? So we're here on the third Regents problem. The real challenge would be 6th grade math, right? Thinking about that. You'd have to figure out what the GCF of 108 and 20 is. 34 is interesting because here we're dealing with something that's going to be important down the road, and that's what do we do with negative signs when they put them in unusual places? Well, the GCF of 20 and 16 is obviously 4, but I'm going to put a negative 4 there because I have to somehow get by. There's the W that matches in both of them, and I could write that out if I wanted to. I mean, 16W is 4 times 4 times W, and 20W squared is 5 times 4 times W, and that justifies that, but that's a negative sign. So a negative times a positive is a negative, so that's the GCF. And what do I have left? Well, I have a 5W here. I check, come up with the answer. But now what do I have to put over here to make it work? I have to put the negative sign. And that's something we're going to talk about. Why did I put the negative sign here? Because a negative times a negative is a positive. And this is one way of doing it. Okay? There are other ways of doing it. You could say 4W times negative 5W plus 4. Or you could do 4W times 4 minus 5W. I've seen it all these different ways. I would say this is the most elegant, but this is probably the answer they were looking for. In every case, you check for coprimeness, and you multiply using the distributive property backwards to make sure that you come up with your answer. So there it is right there. Okay? And now we go on to the number 35. And that's the same idea. There's really no big deal here. I'm going to give you more. Like I said, I'm doing them on the board. I'm going to give you some to work on today because kids are letting me know it's not the greatest. And here, I just have to notice that I have 3 to the third, C to the third, and C to the second. So we want to make sure we take that all into account here. And isn't 32 a multiple of 8? So really, it's 8C squared times 4C, check. 8 times 4 is 32C times C. And then, since it's the same as this one, what's left? 1. Okay? So you can double check yourself going backwards. You could have written out the C's. Let's see, 4 times 8. I'm doing this one now, C, C, C. Okay? And then 8, C, C. And there you have it, where you matched your GCF. Okay, which is 8C squared. And what's left here? Well, there's a 1 there, right? And what's over here? C, 4 and C, and then the 1. Remember, you always go through this in basic Regents math. When there's nothing there, it's really 1 times 8, just like a coefficient. Okay, let's move on a little quickly here. See if we can get everything in, get them all done this morning, get this posted off. And now I'm looking at the third one, and here it's just a common sense problem. Come on, guys. Think money. Only a quarter will divide both of these guys. It's so obvious to me, at least, that the GCF is 25. And I'm not going to work that out in great detail. I'm just thinking money. So how many quarters are there in $3? Do the math. There are what? 12. And I'll write the D squared. I like to do problems a different way. Just do it. 4 quarters is $1, right? 8 quarters is $2, okay, right? And then this better be co-prime, right? So we'll have to think that one out. But there's 7 quarters and $1.75. Factor out the D, which you must do. Otherwise, these aren't co-prime. See that? They share a D. And there you have your answer. You can double check it just using the mental method I used before. Okay, and finally we come to a problem that might deter some of the weaker students. And I'll just use the factoring method on this and match it up. And I'm going to give you a couple more for your assignment soon. But I'm doing 15, and I'm not trying to do it in my head in this case. Okay? Although I see right away that 60 is a multiple of 15. You've got to be able to do that in that. But with all these x's and y's, it's probably best here, and since we're doing it for the first time in the beginning, I'll just quickly factor this and notice that there are 4 y's here. And quickly factor this being 15 times 4. So I'm just going to write 3 times 5 times 4. I didn't even have to write out 3 times 5. I'm sure most of you get that. So that this is bigger than 15 by a factor of 4, I'm trying to say. But here there are 2 x's, and here there are only 2 y's. So the GCF is whatever we match. So that's 15, 3 times 5. Now what else are we going to match here? Well, we're going to match 1x. Got to be careful here. Easy to mess up. Remember, I'm doing the GCF. And then I match up on 2 y's. Got them right there. Okay. And so it's easy enough to mess these up, right? And now I circle what's ever left over. And on the top, there's y squared. That is y times y. And on the bottom, there's 4x. But I feel confident that I'm good now, because after all, these 2 terms are coprime. It's true that it's a square here, but there's no y here. They don't share anything except the 1. A quick check going backwards, and it checks out, and this would be the answer to the last one. When I do the next one, I'll talk a little bit more about LCMs as well as GCFs, but that's the answer to the last one. And we're almost on 15 minutes. So there I did all the problems. I will assign more from the same book shortly.